Hello everyone, my name is Celeste Navarro. I will be speaking for both myself and my partner Pete Safrazian for our research titled Forecasting Box Office Revenue Through Predictive Analytics. Over the past few decades, box office revenues have greatly increased. This encouraged us to research which variables predict total box office revenue best. We then select a dataset that contains almost 2,000 movies from 2006 to 2018 and considered 4 different approaches to construct the model. As we continued our research, we discovered many great published works that include a similar objective as ours. Here I have listed some that we looked into for inspiration. Looking through, we noticed that linear regression was the most popular model used, with neural network being another popular choice. We decided to focus on a method that wasn't commonly used, that being a regression tree, or also known as a decision tree. There are 2 basic steps in building a regression tree. First, the predictor space is divided into a distinct number of regions. Second, for every observation that falls into a specific region, the same prediction is made. To cut the predictor space, we take some predictor, call it xj, and we use a cut point that splits the predictor space into 2 regions. Repeat the process for each region created, using a different predictor and cut point until a stopping criterion is reached. The tree will then look similar to this, where the main decision node, also called the root node, is held at the top, followed by decision nodes and leaf nodes. As previously mentioned, our dataset consists of 1,936 U.S. movies from 2006 to 2018 with 13 variables. The included variables are listed on the right. We decided to create a new column of the total revenue, which is the sum of the domestic box office and international box office. We decided to train and test the dataset first. 70% of the data was used as a training set, and the remaining 30% was used as a test set. As we constructed our model, we decided not to include certain variables such as the movie name and movie ID number, since they are insignificant to predicting the total revenue. However, we noticed that as long as we included domestic box office and international box office in our model, all other variables were not factored into the decision tree, resulting in the same tree and predictions made. Therefore, we were able to narrow down our model to only 2 predictors, domestic and international box office revenue. Here we have our decision tree, which is constructed almost entirely using the international box office. More importantly, we graphed the actual values versus the predicted values to see how well the model performed. The graph is incredibly linear, but as values increase, the model becomes less accurate in predicting the total revenue, resulting in heteroscedasticity in our residuals plot. This model had a mean squared area of 3.66 times 10 to the 15th and a mean absolute deviation of 3.79 times 10 to the 7th. Next, we performed a 10-fold cross-validation and removed any redundant variables beforehand that were either insignificant or repetitive at predicting the total revenue. Unfortunately, we were unsuccessful at producing an effective model. Our 8th model appeared to be the most linear and resulted in a mean squared error of 1.26 times 10 to the 16th and a mean absolute deviation of 7.39 times 10 to the 7th, both numbers being higher than those from the training and testing model. Considering our results, we are interested in continuing our research using either neural network or multivariate adaptive regression splines. I'd like to thank those who are watching this video for listening to me speak, and if you have any questions regarding our work, please feel free to either contact myself or my partner Pete. Thank you.